Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.25. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. According to this law, a cumulative supply and dropped voltage in a closed loop is always equal to 0. Now move towards the problem. Exercise problem number 2.25. Find voltage VFB and VEC in given below figure. This is the circuit diagram of given problem. We have to find the voltage between these 2 points labeled as VFB and these 2 points labeled as VEC. Voltage VFB is indicating that F will be on higher potential than point B. Similar case will be here. VEC is indicating that point E will be on higher potential than point C. If we observe, the only information provided inside the circuit is in the form of voltage, and it is also asked to calculate the value of voltage as well. No other parameter is specified. So we will use Kirchoff's voltage law for the solution of this problem that is purely based on voltage. Before starting the solution of this problem, first we have to identify the direction of current inside this closed loop. We will assume the direction of current is clockwise. You may take counterclockwise as well. It totally depends upon your own choice. Now we are interested to calculate voltage between these 2 points F and B labeled as VFB and between these 2 points E and C labeled as VEC. First we will calculate voltage VFB. For that purpose we will apply Kirchoff's voltage law for this imaginary closed loop. We will start from here. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign, 2 volt. Similar case will be here. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign, plus 2 volt. For this voltage source, current entering terminal is negative, so voltage across this voltage source will be taken with minus sign, minus 12 volt. At the end, current entering terminal of VFB is negative, so voltage VFB will be taken with minus sign. Inside this equation we only have one variable, that is VFB, and we are interested to calculate its value. So we will place this VFB on the other hand side of equal to make it positive VFB and add these values together to calculate the value of VFB, that will become minus 8 volt. 4 volt will subtract from minus 12 volt and it will become minus 8 volt. Now we will calculate the voltage VEC. For that purpose we will apply Kirchoff's voltage law inside this semi-closed loop. We will start from this. Current entering terminal is positive, so voltage across this voltage source will be taken with positive sign, plus 3. Similar case will be across this resistive element. Because current entering terminal is positive, so its voltage will be taken with positive sign. And move to the VEC. Current entering terminal is positive, so VEC will also taken with positive sign. Again, inside this equation we only have one variable, that is VEC, and we want to calculate its value. So we will add 3 plus 3 and place it on the other hand side of equal to calculate the value of VEC, that will become minus 6 volt. So value of VFB is minus 8 volt and VEC is minus 6 volt. This was exercise problem number 2.25. Thank you. See you again in next video.